Alright guys, so today I want to show you how to run the unconsolidated undrained test on a clay specimen in the triaxial machine. So again, the triaxial cell right there and the acrylic tube that goes inside of it, like that. So that's what this looks like. Then this is the top area where we apply the load and the air pressure to the cell. This is a wire saw that we're going to use for cutting the clay. This is a close-up. There's that little wire right there that's going to help us cut the clay. This is just a spatula where we are going to use for just trimming the clay. This is our membrane. This is again another split mold, and we use this to kind of chop off the height of the clay specimen. Once we've made it into a round shape like this and it has extra height, then we'll cut off that extra height. This is the loading piston for the Triax machine with the axial displacement dial on top. This is a caliper to help us measure the diameter and the height of the specimen. This is our top cap. This will be placed on top of the trimmed specimen before testing. These are our filter papers that go top and the bottom of our specimen. Some vacuum grease to make the system airtight. A couple of O-rings that are already stretched and ready to go to help us create a good seal on the specimen, make it airtight. And this is our clay. This is what we will actually be testing. This is some kaolinite clay. I'm going to open up the wrap. And by the way, this is our trimming device, this machine that you see right here. It's actually not a machine, it's just a handmade device that is going to help us trim the clay specimen and make it into a round cylindrical shape for testing. So this is what the clay looks like, some kaolinite clay. And you can see that, it actually does fit the diameter of the specimen that we want to test. So what we need to do essentially is cut all of these excess pieces, anything that's outside of the diameter of the top cap and the bottom, get rid of those, and then we will have our specimen ready. So in order to do that, I'm going to place this in my trimming device. I have a little bit of extra height on this, so I'm going to first cut that off. Just chop a little bit of it off and make it a little bit less tall so that I can fit it. I still can't fit it in, so chop off a little bit more from the top. So this is what my specimen looks like right now. So now is the time to place it in the trimming device. I would need to place it in the middle. I'm going to just bring this here and make sure that it's in the middle. And by the way, the diameter of this area on the trimming device is the same as the diameter of the top cap. This is made like that. So now this is something that I have, and I can twist and start shaving off the excess material. So this is how I would do that. So this is, I'm going to use my wire saw. I'm going to place one end of it on this rod and then the other one on this rod and vertically go down. And with that, I'm able to shave off the excess soil. Then I would just turn the specimen a little bit, do another shave, and so on. And keep going until you get a nice round surface and you can no longer remove any excess material. Usually this is the most fun part during the triaxial test because students often find it very satisfying to cut the clay. And then they get too excited and then they cut too much and then they have to repeat it with another specimen. Pretty cool, huh? So as you can see, the shape of my specimen is getting more and more round. And I want to continue this process until I get a very nice surface that's almost like a circle in cross-sectional view. Or from the top view. So you can see that as I'm doing this, I'm able to cut less amounts of soil. Sometimes you need to do it from the bottom because the top area just doesn't have any more for you to shave off. So that's what I'm doing right now. I'm going to be pretty gentle with this because you don't want to shear the clay. The clay is very sensitive and loose. These are very, very thin layers that I'm able to take off, by the way, right now. The reason is that there's not much more excess material coming off. That's getting pretty nice and uniform. Sometimes I use this spatula to just smoothen out the sides. I'm not applying any pressure, I'm just sliding this up and down. This may not be perfect to do, but I just do that to kind of maintain a smooth surface on the edges here, which are better for testing. And this is probably now ready to be taken off. So this is what your specimen would look like after the trimming. You can see that it's pretty nice and round at this point. I could have probably done a little bit more to avoid these kinks, but for this purpose it's pretty good for right now. Then I'm going to place it into this split mold. Now remember, this is the one time that you can measure the weight of your specimen, and you want to do that. So what I would do is I'm going to place it in here, but before that it would have been best if I measured the weight of the mold without any soil in it. So I can repeat the measurement after placing the soil in it. So now you can see that I do have some excess material in height, right? You can see that it fit in the mold, so it's nice and round enough. So what I need to do now is do one more cut here at the end to get it to the right height for testing. So I chopped off the top and the bottom, and you can see that the cross-section of the sample is pretty nice and round, right? Almost a circle. The reason you want to do that is because later on when you're calculating your stresses, you want to know the cross-sectional area of your specimen, right? So if you know the diameter of your circle, and it is actually a nice round circle, then you can use the formula for the area of the circle to calculate your area, and from area and load get pressures that are being applied to your specimen. Basically go to kPa units. Okay, so this is what I have right now in the mold, right? So a nice round specimen that's cut to the height or the desired height that I want to test. The next step is to reweigh this all together and subtract the weight of the mold. Therefore, or by doing that, you would then have the weight of your specimen. So I can open it up like with that. This is what I have in the middle. I'm just going to keep this here. By the way, when you're dealing with clay, you want to speed stuff up a little bit just to avoid letting the clay dry. So the next step is to actually place it in the cell. I'm going to remove this. And for this step, what we need to do here is to stretch the membrane and apply a little bit of vacuum here. So what I did right now is I stretched a membrane over this hollow tube right here, which has a little other tube actually going out. I'm going to connect this to vacuum, and this is what the membrane looks like inside, right? It's not yet stretched, so I'm going to connect the vacuum hose to this, and then I'm going to turn on the vacuum. So let me just show you what this looks like, and then you'll see what it's going to look like when the vacuum is being stretched, or the membrane is being stretched when the vacuum is being turned on. Alright, so now you see that the membrane is nice and stretched out with the vacuum pressure applied. So once I have that, I'll keep it right there. I'm going to bring my sample and place the bottom filter paper. Then what I'm going to do is grab my clay specimen from the mold, gently grab it and place it on the filter paper. I'm going to show you a close-up view right now. And then place the other filter paper on top. So here's my specimen. It's usually good to make your measurements right here, right now with your caliper. So measure your height. Measure the height of the specimen. Maybe make a measurement on this side and then another measurement on the back side, just to make sure if it's all nice and uniform. And also make measurements of the specimen diameter, again at the bottom. You want to be very careful not to squish the specimen while doing this. So one measurement at the bottom, and another measurement at the middle, and your third measurement on the top. Be very careful with that step. And then take the average of the three for your stress calculation. So now I have the specimen ready, so with the two filter papers. The next step is to add the top cap. And now we are ready to place the membrane on the specimen. So my membrane stretched and connected to vacuum. I'm bringing it right here. And what I will do, I'm just going to hold the top cap so that things don't move around, and I'm going to release the vacuum from the side. And what's going to happen is the membrane, now that I release the vacuum, is now all tight and close to the top cap. So the next step is to remove that membrane from the top and the bottom. This is a very delicate step. So now we have just a little bit of excess membrane that we can cut off from the top. We don't need that. And do things while not disturbing the clay specimen as much possible. So this is the step where I'm going to add my O-rings, so 2 O-rings to the bottom, making sure that the top and the bottom cap have enough vacuum grease on them. So here's 1 O-ring, and here's our second O-ring. When you're doing the top ones, you want to be careful so that they don't jump on the clay specimen, because if they do, then we've basically ruined the clay specimen. So be very careful with that part. They do tend to want to jump down. So I'll do it very, very slowly. That's one. And here's our second one. There we go. That's all ready to go. So we have our sample, our clay sample, nice and ready. It's very round and is maintaining its shape. Another way we could have measured the height and the diameter would have been to do it right now after pulling the membrane on the specimen. The trick with that is that if you're measuring the diameter, you would need to reduce the thickness of the membrane from the diameter that you measured. So again, if you measured this, the bottom, middle, and the top, just make sure to subtract the thickness of the membrane before using that value. Okay. So the next step is to place the cell. I have that ready, and I'm going to place this top area. And tighten up the screws. Now that we have the cell ready to go, again, the last step is to add the loading piston to the top of this. Just put this on. Again, you want to be very careful with this step not to shear or fail the specimen. So that's right there. And this is our vertical dial. So I'm going to take the cell and place it on here. Get the loading piston in contact with the load dial. I'm going to close up this valve, and I'm going to apply the cell pressure to the system. Now that I have maintained my contact, I'm going to apply that cell pressure, and now I'm ready to apply the cell pressure. You can see that it's 0, so I'm going to crank it up to 10 psi. So that's 10 psi. This will remain constant for the remainder of the test. And everything is ready. What we need to do is take our initial readings from the vertical displacement dial, the yellow one, which every tick mark is 0.01 millimeters. And this is our load dial. We've calibrated this load dial before and found the calibration factor. Every tick mark on this load dial is 0.0001 inches. It's very important to know what you're measuring during this triaxial test. So the next step is to automate the rise of the bottom plate with the machine and placing it in the automated gear. And other people in the group would be reading the vertical displacement dial and the load dial as the test is running for about 15 to 20 minutes, and you're taking measurements every 30 seconds. So you also need a timer. Alright, so in order to do this, what I'll want to do is switch to fine and place the gear in place. Taking the initial readings of the values for these two and recording them, then I'm ready to set the timer and have this start. So 1, 2, and 3. First, this gear is going to start moving, and then after a little bit of time, once that gear starts moving, that's when actually this test is starting and the plate is being risen up. Right, guys, now that the sample has failed, if you look close enough, you may be able to see that the specimen is now bulging at the top area. You can see some wrinkles on the membrane maybe, which shows you that the sample has failed and reached its capacity shear strength. So that concludes this test. What we're going to do is remove the specimen from the cell and repeat the test 2 more times at higher pressures, so 20 psi and 40 psi. Preparing the sample and everything else is pretty much the same. To take off the specimen, I'm going to release the air pressure, go back to 0, open up this valve right there, and bring down the plate. And take everything off.